4 marks.
Actually, 3 marks. Okay? See the 3 green marks? Or line? Now let me be able to think of that as green again. It is a lime green. Okay? How do those 3 marks show that that has to be 5? Actually 5 meters per second, we'll say 5. Why? You know, when I mark a side like this, it means it's equal to every other side marked like this. So why is this side and this side and this side all the same?
Because it's the same line. It's where you cut along it.
Yeah. When I cut this one, the side that isn't 3 meters per second is this one, right? Which means that on this triangle, this side is this, right? And on our triangle, this trapezoid. And this thin trapezoid that I get here, when I mark this, it's the one that's not 7 meters per second, so it's this one. So these 2 are equal and they add up to 10 meters per second, right? So it's 5 meters per second.
And guess what?
Okay. Okay, now, having determined this, let me show you why we're doing this. Anybody run off with my white chalk?
It's right there.
Nah, it's too small. I'll get another piece if I need to. Well, I'll write with this one for right now. Okay. Now, you had the question about a graph altitude. So we've got an x-axis out here and a y-axis, or t-axis and a y-axis, or a whatever axis and a whatever axis, right? T and v, whatever it happens to be. Okay? These 2 sides are not altitudes of a trapezoid. What's an altitude of a trapezoid? What's an altitude in general from a figure? Well, it's measured from the base. Okay? And you've got 2 bases here to the trapezoid that really look like altitudes when you put them on a graph this way, right? So the altitude of this trapezoid is officially this distance here, okay? But we're going to call that the width. And we're going to call these graph altitudes, okay? Not to be confused with altitudes of a trapezoid, but on a graph, we have a lot of really good reasons to do this, mainly because if a graph is in the form of a trapezoid, we can find its area, and its area will have the same interpretation it did up here, okay? In this case, maybe how far you would run in 5 seconds if you started at 8 seconds, if you started at 3 meters per second and accelerated uniformly to 7 meters per second, okay? So if you go from 3 meters to 7 meters per second in such a way that your velocity goes up linearly along a straight line, you get this. Okay, so these are graph altitudes of a trapezoid, and it's always going to be trapezoids. And here is your graph width. I'm going to put quotes around width, quotes around graph altitudes. I won't always put quotes around those things, but often I will. And you got to think, there are kind of quotes around it. The reason there's quotes is the graph width is really a displacement. Okay? And the graph altitudes are really displacements from here to here, here to here. So if you had a trapezoid that was underneath the axis, your displacements would be negative and stuff. Don't worry about that right now, I'm just mentioning it, okay? Right now what I want you to focus on is the fact that, well, if this is A and this is B, that your midpoint altitude is halfway between A and B, right? What's halfway between A and B? How do you calculate the number halfway between two numbers?
You add them both up and then divide.
Add them, divide by 2. In other words, you do what we usually think of as averaging them, right? You're actually finding their mean, because average doesn't always mean mean, but I'm not going to worry too much about that. So,
A plus B equals C. C divided by 8.5.
okay, so your midpoint altitude is A plus B over 2. That's this. And, as Andrea showed, I've got to draw it just a little differently, but it's completely equivalent. This triangle being congruent to this one tells you that this is totally equivalent to a rectangle with the same graph width and this average graph altitude, right? Everybody got that? Okay. Well, that also needs to incubate before it becomes second nature, but I think everybody sees it quite well, and y'all did a really nice job of discussing this and arguing about it and coming up with various ways of proving this, right? So 2 thumbs up to you. Okay? So very nice, very nicely done.